Welcome to the Replic8 tutorial video on constraints. Constraints are restrictions that can be applied to parts and their behaviors in order to mimic the real-world physical restrictions that the student will experience during a maintenance procedure. The constraints in Replic8 are defined using an XML-based script that specify the state that parts need to be in, as well as the condition that needs to be set before an action can take place. Configuring these constraints early in your lesson development will make it easier for you to interact with the environment. For example, configuring your environment early on so that a part cannot be removed until the bolts holding that part in place are removed will make it easier for you to record lessons, and because constraints are applied to the environment. Coupled with the physical constraint system is the concept of ganged actions. These actions allow the lesson developer to customize a level of interactivity that is required of the student based on the lesson objectives. For example, if your lesson objective is to ensure a new student knows the location of all the bolts required to remove an item, you can configure the environment so that students have to select each nut, bolt, and washer to remove them. If your lesson objective is to provide refresher training or overview of the steps, you can configure it so that the student only needs to select any one of those items, and the rest of those items will be removed along with the selected one. Once we get more into the concept of constraints, you will see the potential use cases for this feature in your own lesson development. Now, before we begin, let's take a look at our content without any constraints. Here we have our content loaded in the 3D viewport, and I've already set up the behaviors for all of our parts that we will be using in this tutorial. Now watch as I select any part with a behavior, and it will animate regardless of its position or relation to other parts. I'll click on this washer, and it'll remove. Obviously, this does not resemble a real-world restriction. And by adding constraints, we can close the disparity between what the student will learn and what they will experience in a real-world procedure. So let's add constraints. Go over to the Resources panel and click Open the Constraints folder. Right-click on Physical Constraints and select Open or double-click, and the Physical Constraints tab will open in the Documents panel. Now before we begin, let me review some of the buttons we will be using. We have the Preview Mode button and the Enable Physical Constraints in Preview Mode button. Both of these will need to be clicked in order to view our physical constraints right after we make them. However, in order to make constraints, we need to be in Edit mode. Now, in the Physical Constraints tab of the Documents panel, we see the syntax for constraints, and this will help us to make easy edits to our XML script. This script is currently commented out, and in order to enable it, all we have to do is delete those comments. Now remember the difference between actions and conditions. The action is the part's behavior that we defined previously or its animation, and the condition is what is or is not restricting the action from taking place. Let's use the same intake bolts and washers that we looked at before and create constraints that require the student to first remove the bolt before they are able to remove the washer. Since we already have our syntax, all we have to do is put in our information. And to put in this information, we can use the path auto-completion feature of Replic8 to speed up the process. Let's do that now. Simultaneously hit the Control key and the space bar, and it will bring up a list of attribute paths to choose from. Select Equipment, and then input a period to bring up a list of our parts. Select the washer. Now the washer is the part for the action, and the bolt will be the part for the condition. After we have our part selected, put in another period, and select Animated Toggle. That's the behavior that I have set up for all of our parts. Input another period, and a list of attributes will appear. Select State. Set value is the correct name for this action, indicating that it will set the value of the state attribute. And the argument portion indicates a new attribute value for the action. In this case, we're dealing with an animated toggle's behavior state value. This can take a value of either 0 or 1 to indicate one of the toggle's two possible states. The value can also be an asterisk to indicate that the action could be constrained regardless of what value the state is changing to. So I'm going to input an asterisk. Now, you can think of condition as what is stopping the action from occurring. In this case, the washer cannot be removed unless the bolt is removed first. So, the script will be similar. However, it will be the bolt in place of the washer. So choose bolt 1. Again, our behavior is animated toggle, and we're changing the state attribute. Value is the correct name for this action, and in this case, the argument is 1, which is for the removal of the bolt. Now, I have the constraint for the first washer set up, so let's preview it. Select Preview and enable our physical constraints. Now let's try to remove the first washer without removing the first bolt. It's constrained. I can remove the bolt and then I can remove the washer, but I cannot do those the other way around. Okay, now that I have the constraint for the first washer set up, I'm going to set up the constraints for the other washers of the crossover intake. Since the syntax is relatively the same, I'm just going to copy and paste each constraint and then simply change the numbers of them. So copy and paste. This will be bolt number 2, or washer number 2, excuse me, and then bolt number 2. Paste. Washer number 3 and bolt number 3. Paste. For washer number 4 and bolt number 4. Alright, let's preview our constraints. I'm going to try to remove this washer, and it's constrained. All of our washers are constrained. Now let's look at two important variants of constraints: gang by any and gang by first. Gang by any allows you to link together similar parts and allow their action to occur at the same time when clicking on any of the linked parts. This is beneficial for a refresher or overview lesson, as we talked about earlier, where all parts will be removed at the same time. The gang by any action follows the same XML script we saw earlier for the basic constraint action. It just doesn't have a condition. So let's enable the script by removing the comments. Again, it'll be the same script, just without the constraint. Equipment, period, bolt number 1, period. Its behavior is animated toggle. We're changing its state. Set value is correct. And again, we're removing the bolt, so it is 1. Now, I'm just going to copy and paste this and simply change the numbers. Paste, paste. Here we have bolt number 2, bolt number 3, and bolt number 4. Alright, let's view this gang by any action. Now, I should be able to click on any of the bolts and they should all remove at the same time. There we go. Now our constraints are still intact. I can't remove the washer first, but I can remove any one of the bolts and all of them will be removed. Now let's review gang by first. Gang by first allows you to link together parts that have actions that are closely related. For example, let's say that in order to remove all the bolts for the intake, the third bolt must be removed first. And like gang by any, gang by first will have the same XML script for the action. But order is important here. Since the third bolt must be removed prior to the other bolts, then that action must come first in the syntax. So first what we have to do is disable our gang by any action. To do that, we simply comment it out, and then we enable our gang by first by deleting the comments. Now we just plug in our information. The syntax is still the same for gang by any, except the order is different. So equipment, period. I'm going to pick bolt number 3, meaning that it has to be selected first before the other bolts can be removed. And we're still talking about removal, so the value is 1. And then now I'm just going to copy and paste this. This way all I have to do is change the number. So when bolt 3 is clicked, bolt number 1 will be removed, then 2, as well as 4. Alright, let's view this. So, because our constraints are still intact, I can't remove the washers, but I can remove a bolt separately, or if I picked the one signified bolt, which is bolt number 3, all bolts will be removed. And there we have it. That's how to create constraints in Replic8 to ensure that your virtual environment accurately represents the real-world experience. For more information on how to create lesson training content in Replic8, check out the tutorial videos or contact us at support@disty.com.